Hello, everyone. I am Mayank Srivastav. I am one of the PMCs for Apache Pinot project. Really happy to have this opportunity to host you all here in this forum. We had met a few earlier in the year. We discussed the roadmap, and we felt like this is a good time to kind of reflect back on all the excellent things that we have as a community done for Pinot, how the growth has happened. So with that, I will quickly start sharing some of the updates from the community side, and then we have a packed agenda. So we'll get going. First, a good call out. Earlier in the year, we reached 5,000 members on Slack. That's a great milestone. Looking forward to another 5,000 very quickly, and requesting help from everyone in the community to kind of spread the word, how you use Pinot, how you talk about it. The more we talk about it, the more we discuss, the more community grows. We added a bunch of new commuters. Thank you to each one of you here, making a great impact. We are an open source community, so really love to have more and more commuters added to the community, added to the project. If you are interested, would love to see your contributions, would love to get you on the committer list. Sharing a little bit more on the community growth. We did cross 5,000 members not that long ago, but we already added close to 200 more members. Amazing growth in the past couple of years. It's almost 10x. So really glad to see that. The community, while it is more on the Slack, the most active or live forum is Slack. We had about 32,000 messages exchanged. A lot of them are mostly question and answers. See a lot of engagement there, so really glad to see that as well. We see about 400 average monthly active users, and only anticipation is to see that number grow. As a global community, we have a lot of forums distributed across 105 groups across 39 different countries. And our DevRel team did an excellent job sharing or hosting about 60 meetups. So amazing to see that as well. On the developer impact side, we had about 350 odd contributors last year. 50 of those were new. That's a great statistics for a open source project, but the sky's the limit. So the more contributions we get, the better it is for all of us. We added 11,000 commits, 230,000 lines added, 90,000 lines deleted, which is also important. You don't want to have legacy code hanging around there. So really glad to see that as well. 13 million Docker polls and 5.5K GitHub stars. Doesn't hurt to have more. If you haven't started, please do that. Would really appreciate it. Pinot is actually one of the greatest assets of Pinot is its community, all of us, and would really love to see the community grow even more beyond leaps and bounds beyond where we are today. And a call for help here for the community is to kind of help engage more with the community. And here are certain forums. Feel free to if you run into an issue, you have a fix, feel free to contribute to the code. You find some code or PR interesting, please do review it. Design discussions are always open. Feature requests, if you are a user of Pinot, would like to see something, feature requests are a great way to do that. And most importantly, one of the areas that we kind of get feedback on is, the docs could be better. So if you run into a small docs issue, the ask or the request is to kind of also help us improve the docs as well. If you are a power user of Pinot, you're using successfully in production, really love to see your success stories shared across the community and even outside the community to kind of get that expanded. Meetups are a great way. Talks and also blogs are another way. Again, for the community, the more vibrant it is, I think the right forum right now for all communication is on Slack. So the more questions we ask, the more folks we get who can actually help us answer questions. That's some area of growth for us, and also even organize local meetups. That would be an amazing help. With that, I will give it to Yardan, who will help us what the DevRel team has been up to.
Thank you, Mayank. Hi, everyone. Yardan from the community team at Star Trek. So in terms of recognition and momentum, this year we put some efforts on brand alignment. One of the highlights was launching the new Pinot open source website. As part of that, we also did a brand uplift. You can see here at the bottom the two different logos. On the left is the new Pinot with the new color palette and a little bit more distinct glass. On the right one is the old one. So I also added a link here to use the new logo kit. So make sure you're using this logo kit for alignment and using the correct logo. As part of this website, we added some new Apache Pinot company story. If you want to be featured and share your company story, please go into this page, add the story, and you will be featured. As part in addition to that, Pinot had 8 million media impressions in 2024, featured on different publications such as Forbes, the New Stack, and others, reflecting the interest in real-time analytics and continuous growth of Pinot. Having 5,000 and almost 5,000 followers on X, 400 new this year. We really want to see this number growing and hitting the 5,000 followers as well. So if you're not following, follow. In addition to that, I opened a new Blue Sky account. The new channel on the Apache Pinot Slack. If there are any resources or posts you think need to be featured, please Slack it there and we will feature them. In addition to that, here you can see the Apache Pinot adoptions, a lot of new logos. And in the next slides, you can see those logos divided by different sectors. So many use cases across different sectors and verticals. And as I mentioned, if you want to be featured, and we would love to feature all of your cool stories and use cases, go to the Apache Pinot website and add your story there on the page. Thank you.
Awesome. Yeah, that's would really love to have this page have filled with more and more logos. So feel free to share your success stories. Speaking of which, one thing that we wanted to do and have started doing this time is we have two guest speakers today who are users of Pinot in their organizations, running it in production, and would like to share their stories.
Hi, my name is Ilam. I'm part of the team that helps run Pinot Infra at HubSpot. So HubSpot is a customer relationship management platform, and our business use case for Pinot has been to build a multi-tenant analytical suite for different use cases. I think it's best explained through like an imaginary HubSpot customer who is like a winery that is selling/purchasing wines across stores and customers. And we like to track their events and have them ingested and see analytical dashboards and have filters on them. The winery can also decide to send out marketing emails and see how their conversion rates for the different emails work. These are some of the business use cases that we have for HubSpot. Pinot has been at HubSpot since 2023, I would say. It's hosted on AWS using Kubernetes, and we also have our own internal folk for bug fixes or contributions, which we have done for some of the bug fixes and some features. We are completely TLS or SSL enabled, including, which is next up is multi-stage engine. We also use probabilistic counting using sketches. There are a lot of queries that run distinct on them and tiered storage. A scale of one example cluster that we have, which is 500 billion records and 150K segments. We have a little bit higher query latency due to distinct measures, but in general, it has been good. Most of the other use cases have been less than 100 milliseconds. Our experience with the community has been great. We could reach out on Slack or GitHub issues, and the turnaround time has been generally the same day, which we have been happy about. Sometimes troubleshooting unhappy paths, happy path, you can go on a documentation. Unhappy path, sometimes you have to rely a lot on the code or go back and forth on Slack. We also got good feedback on our Pinot PR contributions, which we're happy about, and we'll keep going. Yeah, thanks so much.
Hello, everyone. Thanks. I just to introduce myself. Myself, Jatin. I'm part of data platform team, and Kareem. What's Kareem? So we are a first everything app company in the Middle East region. And our vision, our purpose is to simplify and improve the lives of people and build an awesome organization that inspires. So, and why we need Pinot and Kareem, right? So, so we have used the everyone uses the visualization tool, I think, like Tableau, and it has a very important feature called abstract. So what people usually do with abstract is, they build the custom queries and save them as an in-memory table for server, in the server itself, in the Tableau itself. And we want to move away from the Tableau, right? So how can we do that? So if you see here in the problem statement, we cannot migrate from Tableau as superset doesn't have this feature. So we want to replace it with the open source superset. And we want to build this functionality where the dashboard will be loaded as a super fast, like from a flash. So I want to just go through the architecture, how our architecture looks like, how we use Pinot in that to empower dashboarding, visualization is super fast, or ad hoc analysis want to do that. So if you see on the left, if you see the UI layer is the Kareem Insights, and then we build this Flash service. And in the Flash service, we have all the executors in place like Pinot, Hive, MySQL, and then we use Trino to write it to the Pinot. So people who wants to have their queries, aggregated queries, or they want to do some transformation, anything, they can use this Trino to onboard the query, and then they can write directly to the Pinot cluster. And super thanks to Elon, I think is Nicole, so who helped us, to helping to write this connector in Trino. It's not in production yet, but I hope should be soon. So you can also use that to write a batch data through Trino into Pinot. The latency is super less, like 1 ms, and our dashboards and everything, is loaded super fast irrespective of the data in. So what about the scaling of the Pinot we have on the Kareem? And this is just a one use case I'm representing. Apart from the real time that normally uses, is we used to Druid for our real time, for our events and everything. But Pinot is just like awesome. So Pinot just we're gonna replace it. So, and then we deployed it on EKS with stateful sets. We use Argo CD for our deployment. We batch ingestion of our Trino. We have dynamic scaling in, and then what next is like just deprecation of the Druid. And the stats for Pinot is like we have 2 clusters, and experience overall is very awesome, to be honest. And thank you very much, community, for that.
Awesome. Thank you, Jatin. Thank you, Lam, for sharing your use cases. We'll request more and more members of the community to do the same. All right, let's dig deep in for all the things that we have been working on as the developer community of Apache Pinot. Let's start with the query engine, which is the brain inside of Pinot that helps compute all the numbers, those really fast. We have Gonzalo and Yash talking about it.
Hey, yeah, I'll be taking this one. Hey everyone, I'm Yash. I've been working as a software engineer at Starkey for the past 7 or 8 months, and I recently became a committer on Apache Pinot. I mainly focus on the query engine side of things. And firstly, today I'll be talking about the query time improvements we made to null handling. This work was done by Gonzalo and myself, but since Gonzalo is on vacation currently, I'll be presenting the slide. So firstly, column-based null handling was introduced as a way to configure nullability at a column level instead of a table level. And this finer granularity is important from a performance perspective because column nullability affects performance negatively. And in many use cases, not all columns of a table need to be nullable. Also, it's important to note that column-based null handling is now mandatory for null support in the multi-stage query engine, which has null handling on by default in all the intermediate stages. We do plan to enable null handling by default in the leaf stages as well, which is a wrapper on top of the single stage query engine. Furthermore, this year we added null handling support to most of Pinot's aggregation functions. So earlier we had very limited null support where most aggregation functions would use the default value, but now most of Pinot's aggregation functions do support null handling. We also made some enhancements to support null handling in group by and group by MV columns. Then we made some enhancements to make sure that there is no additional cost for aggregations when query time null handling is enabled, but there are no actual null values in the columns of a segment. With these changes, we saw a performance improvement of up to 20x on aggregations with null handling enabled by making better use of roaring bitmap APIs. So this is the case when there are actual null values as well. And finally, the star tree index can't currently be used when there are actual null values in the columns, but we've made sure to use the fast query execution path wherever there are no actual nulls, even when null handling is enabled. And this is true for aggregations, filters, group bys, and any part of the query. Yeah, that's it from me from the null handling side.
Thanks, Yash. This takes us one step closer to being Postgres compliant on the query side. So thank you so much.
Thank you.
Next, we have Ankit talking about the time series query language support.
Hi everyone, I'm Ankit from Uber, and I'm excited to talk about the time series query language feature we are working on. So essentially what we will do as part of this is that you will be able to run time series query languages such as PromQL, which is I guess like something that everyone knows. Then M3QL, which is one of Uber's uh, time series query languages, and many, many more. So essentially like you can plug in the query languages, and the way they run is they run very natively in Pinot. So you will have all features that are supported in the actual query language in Pinot while querying Pinot as well. And you can see the example on the bottom right. So this is like an example of an M3 query against a Pinot dataset. And you can see that what this essentially does is like it charts day over day metrics for broker events. And as you can see, the syntax is very simple here, and you can like mix and match here. So for example, you can move out the moving 1 hour sum, for example, and change it immediately to something else. Or you can change the sum to a max, or you can like add another grouping set, or you can just do as percent. So there is we also have a bunch of functions where you can just do one series over the other series. So everything is like super easy with this. Gap filling is also easy. And the reason we decided to build this was because over the last 2 years, we have seen like a lot of increase in an interest in using Pinot for observability use cases, specifically for the high CAM use cases, which are high cardinality metrics. And as you folks know, like Pinot is good at high CAM, but what is usually like probably a contestable argument is that SQL often becomes limiting for time series queries. That doesn't mean that SQL is not good. Like SQL obviously is one of the industry standard. It's very powerful. But for time series query languages, you are looking for simplicity, and you're looking for a way where you can just quickly do gap filling and quickly experiment with the query. And that is what time series query languages allow you to do. And I have linked like a bunch of links which should help you understand more about this. And we are already running this in Uber, and we're running this at around hundreds of QPS. And this will have a scalability profile which is similar to the V1 engine. And in fact, we're going to bring some of these ideas that we're using to scale time series query languages to the multi-stage engine as well. So yeah, that's pretty much from my side.
Yeah, thank you, Ankit. I think this is a game changer for Pinot, having Pinot be as used as a storage engine and a query execution layer for something like metrics. Next up, log search, Ting and Chris.
Hi, I'm Ting. So I will talk about this slide. Log on Pinot. I think we built this product actually in Uber. I think our primary goal actually at the time was to replace an alternative OLAP engine, ClearHouse, used previously at Uber. It was very hard to operate, has a lot of performance issues. And basically, the application you will look at is basically what I show in this corner. Actually, this is a pretty, I believe, up-to-date log analytics product. You can perform traditional log search, but also kind of aggregation functions, structural search, and so on. It's a very liked product within Uber for thousands of our developers. In order to build it, basically, we actually do a lot of things to help Pinot to advance. So one of the, I think, key contribution we made is basically we drastically improve Pinot's routine text integration. Chris did amazing work here. Basically, he shared a lot of talk in the previous meetup. I encourage you to take a look. And also other things we have done is basically we actually leverage Pinot's function to store and retrieve big block data, which is commonly used in log data environments. Actually, this is a good, I think, feature of Pinot. I think we kind of polish it. And then other improvements on Pinot. Finally, about numbers, right? So basically, after we make it in production use in Uber, today, actually, we stand at 3.9 success rate for query success. This is a great improvement over the previous generation. And also, amazingly, the query latency was cut in half. And finally, with this better architecture, we save Uber millions of dollars annually. So this is a great success. I think this is right now. I think we'll share more during stories behind how we build it later. Thank you.
Awesome. This is very exciting. Thanks. I think especially seeing something like Pinot saving multi-million dollars at a company like Uber with the time series enhancements and the log search, I feel like Pinot is all set to be a key component in the observability stack. So looking forward to it.
Thanks.
Next up, we have cursors from Rajat.
Hi, I'm Rajat. I work at Startree, and the first feature I'm going to talk about is cursors. We built cursors because more and more application clients are consuming large result sets, and cursors helps these application clients in a couple of ways. First is to help the clients manage their resource usage because they can process a slice of the large result set at a time. And secondly, it helps to also simplify application logic. For example, if you have a UI which is paging through a large result set as a table or a graph, you can delegate the slicing to the database instead of the application building that logic. The way cursors work is that the application client can request a cursor when submitting a query through the standard API /query/SQL. And if a cursor is requested, a slice of the result set is returned, right? And then the application can continue to page through the result set by using another API, result stores /request ID by results. So this is keyed by the request ID that the application gets as part of the submission. Application client can page through the slices as it wishes, right? It can go forward or backwards and so on and so forth. The other nice feature about cursors is that we also exposed an SPI. So you can store these responses in different storage systems, for example, databases, key value stores, and even file systems, right? And we have implemented simple PinoFS-based response store, which also works with blob stores like S3 and so on and so forth. Thank you.
Awesome. Thank you, Rajat. All right. Looks like we have a bunch of memory optimizations from Vivek and Dino from the LinkedIn team.
Hey, I'm Vivek. I'll talk about the first memory optimization that we did. It's a heap memory optimization suited for on-heap string and byte dictionaries. So for a couple of use cases at LinkedIn, we did observe that the heap usage was bloating when we used on-heap string and byte dictionaries. And analyzing the heap dump with a tool like JXray, we were able to find out that this was mostly being contributed by duplicate values across segments in the column. So the first screenshot on the right basically shows the JXray result from the heap dump. And we were also seeing spiky P99 latency issues caused by increased GC activity over here. So what we did to solve this is essentially use a fixed array lock-free interning technique. So this interning technique opportunistically duplicates frequently seen duplicate values across the dictionary, across segments. And the cost for the interning is paid only once when the server restarts, when during the segment load. And as you can see from the screenshot below, we were able to save around 12 GB of heap usage per host because of this optimization, and it also improved our P99 query latencies by about 35%. Dino will talk about the madvise support.
Hi, madvise is just, we use IMAP a lot in Pinot. And what we found for certain use cases is that read ahead is not useful and ends up kind of like thrashing our page cache a bit. So this initial feature lets you configure the madvise for all of your segment loads, which gives the little bit flexibility here. And in the future, I think we'll look to extend this into even smarter type hinting.
Thanks, Dino. Thanks, Vivek. Amazing optimizations. Personally, I would love to learn more about madvise, something new to me. I will reach out to you, Dino, to get more details. All right. So now let's move on to the multi-stage query execution engine, something that we added a couple of years ago. This was a paradigm shift for Pinot in terms of going from fixed latency or bounded latency aggregation group by queries into somewhat more SQL-like and different kind of workload with this execution engine. So let's see where we are today with this. First up, Jackie. Let's go.
Hi, it's Jackie from Sarchi, and then I want to talk about the lookup join support. So join is a core feature, and then basically that's about the reason why we want to like build the multi-stage engine. But then like with join, usually the performance is bound by shuffling, and then also by like building the lookup table in memory. So that's why we have built a lot of optimizations before to like reduce shuffle, for example, collocation join. But then with collocation join, the limitation is in order to collocate table, the join key has to be the primary key, and then the table has to be partitioned before that. Then actually in the single stage engine, we have a simpler workaround to use a UDF called lookup to join the table. And then the right hand side has to be dimension table, which means the lookup table is already pre-built in memory. So basically we add that support into multi-stage engine by using a join hint. As you can see in the right bottom corner, if you put a hint, and then the multi-stage engine will preserve the like standard SQL join semantic, but it knows I want to use lookup join to join these two tables. And then basically it gives the exactly same performance as VN engine, but you can do way more complicated queries. Like you can work on this unit and then, for example, use this as one side of the join for more complicated queries. And then we have observed like by reducing shuffle and then lookup table build, some query, the latency dropped from 30 seconds to like 2.5 seconds. Thank you.
Thank you, Jackie. Yeah, I remember in the V1 days, lookup join was a key feature, and even in the multi-stage engine, a lot of folks using lookup join. So really glad to see these improvements. All right, next up, we have window functions improvements from Shang and Yash.
Hey, yeah, so we made numerous improvements to window functions in Apache Pinot this year, including new features, bug fixes, and performance improvements. So the processing model was changed from a row-based model to a batch model where the data is first partitioned and then processed in batches for efficiency. We also added support for various new window functions like lead, lag, first value, last value, rank, row number, dense rank, etc. We added support for custom window frames and fixed the buggy default window frames behavior for various window functions. Now you can use range and rows-based window frames in your queries, following standard SQL semantics. The rows window frames can be used with unbounded preceding, current row, unbounded following, or offset preceding and following, while the range window frames can currently only be used with unbounded preceding, current row, and unbounded following. We'll be adding support for offset preceding and following with range window frames in the future. We also added support for the ignore nulls option for first value and last value window functions. And this opens up a bunch of interesting use cases like gap filling missing data. And finally, the window function operator was also made more resilient by introducing configurable cache size limit. And this was done in order to protect the servers from out of memory errors.
Personally, I've seen a few use cases pop up which are more around funnel analysis, where window functions support has proven to be very vital. So really glad to see that, and thank you for that, Yash. All right, Rajat on home protection for memory for
Hey,
queries.
yeah, thanks. So the motivation, like for building this feature, is similar to the previous version or like the previous state of it, right? So the initially OM query termination already exists for single stage engines, right? But it wasn't available for multi-stage engines. Multi-stage engines OM as well, and we have had experience with it bringing down servers because of badly written queries that misbehave for various reasons, so on and so forth, right? So they bring down servers and brokers. So we extended this protection to multi-stage engines as well. The other nice addition on this side addition is two debug APIs, which exposes the internal state of the feature. Specifically, it provides the memory usage on like for per query across the cluster, right? And this is a sampled approximate value, and I've given an example on the right side, right? And this is pretty useful in various scenarios, right? While triaging, just to see what's going on, which queries take how much memory, and so on and so forth, right? And just to give you a sense of what's happening internally in terms of memory usage for a query, right? So the two debug APIs have been pretty useful and informative as well, right? So that was a nice addition while building this feature. If you think about protection, there are probably two parts to it. One is the resource accounting part and the query termination part. And this feature mostly focused on resource accounting, where we added, where we instrumented the multi-stage query engine operators to report their memory usage to the resource accounting objects, right? And once that was done, the query termination part just worked as is, right? Okay, thank you.
Thanks, Rajat. Yeah, it's really exciting to see a good mix of projects in the multi-stage engine, some from the functional side with the window functions and the lookup join, but at the same time on the resiliency side with features like these. So I think we're heading to a great direction with the multi-stage engine. Ease of use, Gonzalo.
Hey, it's me again. So let's talk about ease of use for the multi-stage query engine. This was all done by Gonzalo, and I'll simply be presenting in his absence. So at a high level, three big improvements were made: new query stats, new explain plan, and comprehensive documentation on all the multi-stage operators and their hints. So the new stats give us extremely granular information about things like the execution time for each operator in each stage of a query, the number of rows emitted from each operator, the fan out, the parallelism, the serialization size, overhead, etc. So Gonzalo has also added some great documentation explaining these new stats and how to interpret them. Also, the stats collection is extremely efficient and on by default. They're extremely valuable to find out bottlenecks in your queries. And the new explain plan for the multi-stage query engine is also a game changer for debugging slow queries. It gives segment level information that you might already be familiar with from the single stage engine's explain plan, alongside the rest of the logical plan from the multi-stage query engine. So for instance, now this allows you to find out if your query is using the expected indexes that you basically wanted to use to speed up your query. Earlier, it was really tricky to debug these sorts of issues where you don't quite know whether a query is using an index that you expect or not. Whereas now you can see the entire plan for a query, including the segment level information.
Thank you, yes. It looks like I spoke too soon. It's not just functionality and resilience, but it's also ease of use. So we're working in all dimensions. Great to see good mix of projects for the multi-stage engine.
Yeah.
All right.
And continuing with ease of use. So two big items here were supporting no downtime upgrades and co-located joins without hints. Again, these are two areas that Gonzalo worked on, or I'll be presenting today. So prior to 1.2.0, Apache Pinot's multi-stage query engine did not guarantee seamless backward compatible upgrades, since it was still considered early release of sorts. However, with the 1.2.0 release, we've put in guardrails to ensure that going forward, all releases will be backward compatible and upgrades can be performed safely without any downtime for queries. A major change was to use Protos to serialize and deserialize query plans that are sent from brokers to servers via gRPC. Earlier, the serialization and deserialization was done via reflection, which is extremely brittle to changes across versions. For instance, class or member name changes. Switching to well-defined protos makes sure that we have full forward and backward compatibility. This was contributed by Rajat. So this work has been done like a combination of Rajat, Gonzalo, and myself. And we also added a regression test suite that runs on each PR and will alert us to any potential breakages in compatibility so that we know not to merge changes that are backward incompatible, which is something that we had been doing prior to the 1.2.0 release. Another big improvement was to allow co-located joins by default when the table partitioning supports it, instead of requiring an explicit hint like earlier. So co-located joins can massively boost performance by eliminating the data shuffling network overhead during joins on tables that are partitioned as well as co-located. So essentially, they are partitioned on the same column, and we know for a fact that data with the same key will be on the same server, so we don't need to shuffle it, and we can just join it on the same server locally. Yeah, I'll continue this one as well. So many performance improvements have been made to the multi-stage query engine over the past year. A major one, again contributed by Gonzalo, was to massively improve the data block serialization and deserialization cost by reducing the number of allocations and copying done. This might sound like a bunch of jargon, but it makes a huge difference in real world performance. It involved adding a bunch of new buffer and IO streams related code and resulted in up to 3x speed up in survey time and up to 8x less memory allocation during the survey. So this should be my last slide. And this is talking about the on by default work we've been doing for the multi-stage query engine. So for the past few months, we've been working to bring parity between the V1 and V2 engines, essentially so as to be able to use the V2 engine by default in Apache Pinot. So some items here include overhauling the function registry for the multi-stage engine. And this basically plugged a lot of gaps where certain functions worked with the V1 engine, but not with the V2 engine. And this also added support for polymorphic scalar functions, which makes sure that we don't run into weird issues like string comparisons and queries failing. We also added some migration assistance tools and added TLS support between brokers and servers, as well as servers and servers for data shuffle. So the high level approach here was basically to identify and fix gaps in the V2 query engine versus the existing V1 query engine using the existing integration test framework. So basically we systematically went about enabling tests to run on both the query engines and either fixed or documented any differences that we found. Talking about the function registry a bit more, we basically introduced a new approach to register UDFs with Calcite. This work was done by Jackie, and this also incidentally added support for polymorphic scalar functions, for which we added certain implementations like comparisons, binary arithmetic, and so on. Talking about the migration assistance tools, a metric was added to indicate the number of executed single stage engine queries that would need to be rewritten slightly to work with the multi-stage engine so that users know how much of an effort they need to put in to migrate their existing workloads from the V1 engine to the V2 engine. There's also a query result comparator API now that was added to support running a single query on both the engines and return the results, as well as highlighting any differences in the results, again, to help you migrate your workloads to the V2 engine. Thank you.
Thanks, Yash. Looks like the multi-stage engine team has been firing on all cylinders, from functionality to performance to ease of use to on by default. So really a lot of impact generated. Thank you. All right, so moving on to the next topic of Pinot Core, let's see what we have here, starting with Shaunak on database support.
Hey, hi everyone. This is Shauna from Startree. So, database support is basically required to bring in a logical multi-tenancy in Pinot. So this was required to support like bucketing tables under a database and then performing operations in isolation. So this feature is required to get rid of the operational overhead that teams need to bring in so that support multiple teams or users on single Pinot cluster. And to get this to work, like under the hood, we are just appending the database prefix to the Pinot tables, and then inside Pinot we are handling this logic and to not like bring this overhead on the client side, so that the client needs to provide the whole qualified table name. We are allowing to pass this database context as just a request header, so that all the usual requests can go through, and just by plugging in the context, it will isolate the request to the required database. So that's how it's implemented. And Startree rolled out its trial accounts, like trial offering through the using this feature, and right now it's supporting like more than 350 trial accounts using one Pinot cluster.
Awesome. Yeah. Thanks, Shaunak. Okay. Is this
Yes.
again with you? Go
Sure.
ahead.
Yeah. So yeah, with the introduction of database, we have also introduced few more query quotas. So earlier Pinot just had the table level query quota. So with database, we have introduced like database level query quotas to limit the number of rate limit the number of queries that are being made to the tables under a database. And same for application level quotas, like to limit the number of queries being made across different databases from an application. So both of these quotas provide a way to give a default quota limit, and also provide specific overrides for any targeted or database or application. So right now, like whenever a request comes on a Pinot broker, like a query comes to Pinot broker, it goes through this hierarchy of checks, like where application, database, and the table query quota is checked before the Pinot like the query is served back. So if any one of these fails, like we fail the query.
Thank you, Shaunak. So yeah, I think these are good features. One of the key issues that has been happening, or rather asked from the community, has been to kind of have quota, application level quotas, and this will probably help us enable that as well. Moving on to this segment is stale API from Rajat.
Hey, yeah, so this is more of a internal functionality, right? But figuring out which segments are stale or have deviated from the table config has been such a bugbear in the past that it's worth calling out, right? So this functionality is reusable. But, the goal is to reuse this in other components, right? Like for example, a segment refresh task to figure out which segments are stale and needs to be refreshed. It's reviewable. There are a couple of APIs to expose this list to the database admin, right? So that before kicking off some background tasks like segment refresh and minion and so on and so forth, it's possible to kind of estimate, hey, this is the list of segments that needs to be refreshed or are stale, and this is the amount of effort, or this is the estimate of effort that will be required to do it, right? So so it kind of exposes what a background task might have to do, right? And then it's scalable because the job of figuring out which segments are stale have been delegated over to the servers, right? So instead of doing it in a controller and then having one single machine having to deal with a big table, right? So the so the functionality of figuring out which segments are stale has been delegated to the servers, and then only the stale segments are kind of sent back to whichever component requires it, right? So therefore, it is scalable. As I mentioned before, it's useful for two activities right now, right? One is to triage, right? Hey, is a segment stale, or and so on and so forth, right? In various scenarios, and hopefully to be used in functions like segment refresh, right? To be able to get the list of segments, right? The core functionality is built within a single function and then exposed through server APIs and controller APIs, right? And I've given an example, samples of the API output on in the right column. Thank you.
Thanks, Rajat. I think for me personally, another bigger usage I can see of this is a lot of times when we have deployments or server restarts for some reasons, if there are unapplied changes, the stale segment rebuild may actually slow down the server restart, right? And then causing the whole deployment to be slow and so on. Having this API kind of helps us preemptively figure out those, as well as take care of those before a maintenance event, for example. So thanks for adding this.
Yeah, for sure. Yeah, thanks.
All right, moving on to the real-time ingestion topic. Let's see, we have Shin talking about, multi-topic ingestion in Pinot. I did not even know that we have this already. So glad to see this.
Yeah, thanks. So this is Jin from Uber. So I will talk about the multi-topic ingestion feature. So as the name suggests, this feature enables a single Pinot table to ingest data from multiple streams, so such as multiple Kafka topics. It's been a highly requested capability for over 4 years, so I'm really excited to share this with you. So this feature helps solve a big challenge, how to do centralized analysis and querying across streams that serve similar purposes or have similar characteristics. So on top of that, it brings Pinot also up to speed with other OLAP technologies, and in some cases, even offer improvements. The core idea behind design is to decouple Pinot's partition concept from the stream's partition concept. We introduce a mapping logic between Pinot partitions and the stream topic partitions, which gives Pinot its own partitioning behavior. Segment names no longer need to match stream topic partition names, but we can still maintain the consistent instance assignment behavior. Plus, changes to the topic partition, like topic expansions, are handled seamlessly without impacting the ingestion. And here's also the best part. Enabling multi-topic ingestion doesn't require any changes on how you define your table or ingestion configs. On the right side, there's a high-level design diagram, and I've also included a detailed design doc if you like to dive deeper into it. And for production use, Uber has already rolled this out on hundreds of large tables. Even tables ingested from over 20 topics show the same ingestion and query performance as if they were split into separate tables. So yeah, that's all.
This is amazing. I'm super surprised. Actually, not so proud to admit that, but still, have we documented this? If not, we should definitely do that. Maybe have a blog around it and so on. This is a very, very key feature. Thanks, Shin, for sharing this. All right. We have support for dedupe from Xiaobing, Haitao, and Deepti.
Yeah, I can take the slide. So, hi everyone, I'm Deepti from Startree. So, thanks to Xiaobing and Haito who developed this feature. So, deduplication already exists in Pinot. So, what it does is basically when a new record comes in for the dataset that is partitioned by primary key, that if the record already exists with that primary key, so it discards the new record during ingestion time. So previously what was happening was there was no time bound set for the number of primary keys that we store in the metadata map. So now we added this metadata TTL feature so that we have that time bound according to the dedupe time column or the default time column that we set. And according to that, we will eliminate the primary keys when the new consuming segment starts. So we also added this preloading feature to bootstrap this metadata during server restarts or rebalances so that the metadata gets stored into the JVM map during restarts. So due to this, you can bootstrap this metadata easily since all the segments will have unique primary keys. This process became much easier. And also like we revamped some of the code that was common between upserts and dedupe. So that was all. And all the documents are updated accordingly. Yeah.
Thank you so much, Deepti. Yeah, dedupe and upserts have been a key differentiator against other OLAP systems. So thank you for doing this. All right, more of upsert compaction and deletion. Pratik, Xiaobing, and Jackie.
Yeah, hey, I'll cover this. I'm Pratik. I'm from Uber, and so now Pinot supports deletions as well. So the motivation behind like making this feature was that we had a use case in Uber where we wanted to support around 500 million deletes per day, and like we wanted infinite retention for those tables. So it was like going to be very costly if we were not going to remove those metadata and the data from disk over time. So what we did is there was a deletion feature in Pinot, but it was only query level deletion that was happening and not actually data deletion. So for this, what we did is we added a new config deleted keys TTL. So once the detail window expires for a deleted primary key, after that we go ahead and remove it from the metadata map. And in Uber, we are using on heap hash maps. So that's why memory cost is also quite important for us. Then we realized that over time, if we don't delete them from disk, so it would again be reloaded into memory for some time during server restarts. So we leveraged upside compaction task here, which was like originally authored by Robert. And then we started using upside compaction at scale. So as part of this, we also productionized upside compaction, like resolved all the bugs and make it production ready at Uber scale. And finally, we found that, okay, we need a consistency because compaction can compact the deleted record first and not the older records. So we came up with a new config where we ensure that the data is consistent and the deleted record is compacted at the end and all the previous records are compacted before. So just to share a production story, right now we have enabled this across 15 plus absurd tables in Uber, and total deletion is around 500 million keys per day, where we are ingesting data at the rate of like 5K new keys per second and also deleting at the same rate. And now this deletion is entirely controlled by the user, and we have like flattened the curves for table sizes and the memory map and everything.
Hey, thanks so much, Pratik. Upset has been a great differentiator for Pinot, but with compaction and deletion, it's becoming even more powerful. And thank you for adding support. All right. Oh, pauseless. Today, maybe I should have asked for $1 billion because all my wishes are coming true with multi-topic ingestion and now with pauseless ingestion. Let's go,
Yes,
Aman and Karthik.
yeah. So me and Aman have been working on this feature. So as you know, like currently in Pinot, whenever a segment commit occurs, especially like we have to like pause all the consumers for that partition. And until that segment commit is finished, we cannot start a new consumer. This is done to ensure like basically the concept of eventual consistency in Pinot. Now, like, but for these right now, people need like real time data, like without any lag for the queries. And they don't want to observe the lag for even a second or so. And while the build can take up to 10 minutes. So the need for this feature arose because of that. And how we are tackling that is like basically it's not very simple to implement because it requires changes in the commit protocol that's written in Pinot in the first place. But we are making sure that we make like minimum possible changes to that commit protocol while also ensuring that the consistency guarantee that Pinot offers of the eventual consistency, like that's not broken. And then secondly, like we are also ensuring that any failure scenarios that occur, basically we are consuming ahead before building, and if build fails for certain reasons. So that is also like fixed automatically by Pinot rather than like users have to do any manual intervention in that case. We have already rolled it out to two of our customers, and like we are observing like really good improvement. So for example, for Epic Games, we are consuming like around in our POC clusters 1 million records per second, and like where initially they were observing with the manual flow, the normal flow like 300 seconds of lag, now they observe just 5 seconds of lag. And that 5 seconds is mostly not because of like basically it's just because they are publishing in the JSON format. Like if this is to proto format, like it will be even less. And that has been running for like around a month now. So, and we have observed like very minimum amount of issues in that cluster. Like hopefully like this will go, like it's still work in progress. Again, you can see the design, like the discussion is open on the Pinot issue. And like mostly we are planning to merge this into the Pinot master like by month or two.
Thank you, Karthik. Yeah, so when I first heard about this ask, I was like, Pinot is already super fast in terms of ingestion. As soon as a row is ingested, it's ready for serving. What more do you want to ask about? But then we came across a lot of use cases where even a few seconds of tolerance of a pause because of segment commit was, for example, in transactional or in finance world, right? It was a blocker for them to be able to use. So really glad to see this getting to life. Thanks, Karthik. All right, we have upstart backfill from Rohit.
Hi everyone. So yeah, I work at Uber. My name is Rohit. I'll talk about how we solve for a disaster recovery solution for upsert tables. So like upserts are a pretty popular type of table in use in Uber, and we have some very long retention use cases, more than a month in some cases. So it becomes natural for us to have this backfill mechanism. So we had a couple of challenges when we tried to backfill solution by replaying the stream. Like you need to handle that scale of ingestion. Some of our tables have like 50 billion primary keys, and it can be few hundred billion rows as well. So that didn't scale out well. So The major limitation that we were having is because upserts don't have a hybrid table setup, because by design, offline table cannot be there in upsert tables. So we needed a way to do batch ingestion to real-time table. And it also should be similar to how the design calls out for it. For example, it should be a pre-partitioned stream. So similarly, we should be able to pre-partition the segment and upload to upsert tables. The second challenge was around, like, even if we are able to upload segments to the Pinot tables, which already exists, the segment assignment did not work as expected. And that was mostly because Pinot wouldn't be able to identify correctly the partition ID for the segments that are being uploaded. Additionally, this backfill also unlocks a few minion tasks as well, wherein you would have to process upsert table segments, and then upload it back to the upsert tables. So how we solved for this is we first defined a new naming convention for segments, which are uploaded to real-time tables only. This is very similar to how LLC segments are named. We encode the partition ID in the name, and that is how segment assigner can know which partition ID it belongs to and then assign it to the right instances. Secondly, we created segment name generator so that the clients can generate these segment names. So it can be either in a Flink job or a Spark job or in a minion task. Thirdly, we refactored the existing Pinot Flink connector that we had, which can now generate uploaded segment names for the table. So at the end, we arrived at a very clean architecture, which we call Kappa plus architecture. So if you see on the right, we have a single Flink job, which can be run in both streaming mode and batch mode. So the streaming mode job is always running, and it is doing business processing on your business Kafka topic and will ingest to a Kafka sync. The Kafka topic is not shown for simplicity. But in cases of disaster in Uber, we also have continuous Kafka ingestion to Hive tables, which is an HDFS. So if needed, we can run backfills for 1 or 2 days wherein we have data loss, and then rerun the same Flink workload in a batch mode. And that would upload segments directly to an upsert table, and it will also hold the upsert constraints of deduplicating on primary key as well. Yeah, that was about upsert backfills. Thank you.
Thanks, Rohit. Yeah, I think backfill is like a key, requirement in any data ecosystem, and upserts having support for that is again only making upserts a lot more, available for users to be able to use. So thanks for doing this. So with that, let's move on to the next topic, which is batch ingestion. All right, batch upload from Ragesh and Manish.
Yeah, I'll take this one. So yeah, I'm Ragesh from Startree. So batch upload, this feature allows us to upload hundreds or even thousands of segments to Pinot in one shot. So Pinot already had the capability to do metadata push. So we leverage that, and instead of uploading one metadata tar file, we can now upload like hundreds or thousands of metadata files in one shot. And how we came about this feature, like for some of our customers where they ran like couple of hundred minion jobs all working at the same time, and they were all trying to upload segments just around the same time. So acquiring the ideal state log became a contention point where it would take, each minion would wait several minutes to get this log, and these updates would eventually fail. So instead of trying to make these hundreds of updates at the same time, we decided why not just do the ideal state update once by updating multiple segments in one go. So that was the approach. And from our tests, we have seen that previously where it used to take several minutes, it completes in like less than a second, so even few milliseconds in some cases. So this was the feature, and the higher level idea here is to have one Uber metadata tar file, which is like a tar of tar files, and which will contain the metadata information for every segment that we want to upload. And in addition to that, previously with the metadata push, we would pass the segment download URLs as part of the header. So there is a limit on the number of headers that you can pass in one request. So what we did was to create one file which captures the segment name to the segment URL mapping and include it in this Uber metadata tar file. And with that approach, we are able to upload like a few thousands of segments in one shot. Yeah.
Thanks, Ragesh. Yeah, I think I remember running into issues where, even when we were able to generate a lot of data using lots of minions or a lot of segments, lots of minions, the choke point actually just shifted from segment generation to the controller, right? And having that choke point removed just improves scalability a lot more. So thank you for doing this. All right, automatic segment refresh. What is that all about, Vivek?
Hey, I'm Vivek from LinkedIn again. So the problem statement here is that whenever there are table config or schema updates, think of it like adding new indexes or removing indexes or adding new columns. These changes are not automatically updated most of the time on the segments and the servers, and they typically either involve calling an API or manually applying these changes. And this has been a source of significant manual toil for us, at least for these large tables that we have at LinkedIn. What we did here is, and the other problem here is that these refreshes are super slow, because if they happen on the servers, we can only refresh a few segments at a time so as to not affect query latencies. So the automatic segment refresh feature basically offloads this job as a minion task. So there is a controller periodic job that automatically detects any changes to table config and schema and schedules a minion task that goes ahead and refreshes the segment. The capabilities that we support today are indexing changes, schema changes like adding a new column, data type changes, and changes of column encoding. We also plan to add new capabilities like repartitioning in the future.
Awesome. Thanks, Vivek. Yeah, I can see this getting coupled with the is segment stale. Is that the API call from Rajat? To kind of like work together to figure out what's stale and then just automatically refresh it, right?
The plan is to use that in the future. Yeah, make the changes.
Nice. Awesome. All right. So with that, let's move on to the next topic, which is enterprise readiness. What do we have? We have Graviton support from Prashant.
Hello, everyone. I'm Prashant. I work for Startree. So a few quarters back, we added native support for Graviton in Pinot. So why this was done is basically this is a low-hanging fruit that we can achieve to reduce our platform costs. It was also widely demanded by some customers, and it's already present in some competitors. So we went ahead and did it. The high-level approach is basically we have to ensure feature parity and performance parity between ARM64 and the corresponding the AMD 64 processors. This entailed, of course, exhaustive performance benchmarking and ensuring that we have all the native ARM64 bindings for all the dependencies. In addition, we added some additional build profiles for OS X ARC64 and Linux ARC64, right? The result, we basically benchmarked Pinot on both the processors, R7G and R6A. Overall, on an average, Graviton was around 5% cheaper for the same ingestion rate, and it was around 7 to 20% cheaper for querying compared to x86. With this native support added, we can basically run Pinot on an ARM64 machine without any changes.
Awesome. Thanks, Prashant. Was there any performance degradation or were we just saving cost here?
Not much. Yeah, actually there wasn't any performance degradation. Yeah.
Awesome. Yeah, I can see a lot of our, actually most of our cloud users are asking for Graviton support. So now that we have it, great.
Right.
All right, next slide.
Thanks, Mank. So coming to monitoring improvements, one major gap that we had in our metrics was that testing metrics was extremely manual and brittle, right? So as you know, we use the Prometheus exporter to translate our JMX metrics to Prometheus consumable metrics, right? And this exporter uses a bunch of regular expression files as configurations. Now, so what ends up happening is if you are making changes to any existing metric or if you're adding a new metric, people are always defensive, because they don't want to touch some other regular expression that might break some existing metric, right? So there's a lot of defensive coding being done, right? And in addition to it, testing is very manual, right? So there's no we don't have any unit tests that guarantee that, okay, these metrics are being exported successfully and the labels that we expect, they are present, right? So what was done last quarter was we basically built a comprehensive test framework, unit test framework to test our Prometheus metrics, right? Without having to set up the entire monitoring stack. So basically, whenever you are adding a new metric, you can just assert on what name you expect of the finally exported metric and what labels you expect. And if any existing regular expression breaks, we basically the test framework catches that, right? So it's very fast now, and very less manual intervention is required. So the test framework has been merged to master. We are in the process to reduce the config file bloat, right? Because we found out using the framework that there are a lot of regular expressions that were redundant, right? We don't need that. So the config files are much smaller now, right? And we are still benchmarking the resource usage improvements, but there was around a 33% reduction on the memory that the compiled expressions occupy, right? This is not the memory that the container occupies, but just the part of the compiled expressions, right? So we're definitely expecting some resource usage improvements. And finally, with this framework in place, we have our migration from Yammer to Drop Wizard in the roadmap, right? And this should be fairly easy now that we have this framework that can just tell us that, okay, we can use Drop Wizard and the metrics are still being exported, right? So as you know, Yammer is no longer maintained, right? So we want to migrate to Drop Wizard, right? So this framework will help in that as well.
Awesome. Thanks, Prashant. Yeah, I mean, it's always kind of tempting to work on, projects on the functionality, but operations is a key part of big distributed system like Pinot to kind of have it running efficiently, and monitoring is a big part of it. So thank you for making these improvements. And looking forward to that Drop Wizard migration sometime soon.
Thank you.
All right, we have binary workload scheduler from Vivek.
Hey, the problem statement here is that we have tables serving production queries. Oftentimes what happens is that some of our table owners have some use cases where they want to run certain queries at lower priority or with lower SLAs, such that it doesn't affect the primary queries, or there's a cap using which it can affect the primary queries. So we built this binary workload scheduler. The basic concept is that it categorizes the queries of the table into two workloads, the primary and the secondary. And the primary is the production queries. Secondaries could be any ad hoc queries or non-prod queries fired. So the primary queries are executed using the default unbounded FCFS scheduler, using which all the queries are scheduled today. And the secondary queries go through a constrained processing where we limit the number of runner and worker threads assigned to it. And it also goes through queuing for staggered execution. So what basically happens is that the primary queries, they can basically end up using the entire CPU, while the secondary queries have an upper cap in terms of the CPU. So they are bound in terms of how much they can affect the latencies of primary queries. So we've rolled this out across LinkedIn, and it's widely used for querying some of our tables using notebooks, dashboards, and dev environments. And I also know that Activision is using this feature for running some reporting queries, and it lays the foundation for a generic query resource isolation feature that we want to soon kick off, for which the issue and the design doc is out.
Awesome. Thanks, Vivek. Yeah, I think this has been a long time ask where, users of Pinot want to be able to run two kinds of workloads. There's a production workload with a very, very high tight SLA, but at the same time, they want to be able to do some ad hoc queries. And the only options are either you're risking your production workload, or you are duplicating your, data as well as the data pipeline, right? And neither of those are desirable. So really glad to see this come into life, and I would love to learn more about your experience on running this at LinkedIn, because I think this is definitely a feature that everybody can use. Thanks, Vivek. All right. With that, I think we're at the end of our presentation. I see a lot of questions already discussed in the chat. We can continue to do that, or what's the agenda next, right, Yarden?
Okay, I think we will be sharing the slides and recording and a summary of this meeting sometimes this week, earliest next week. We will keep you posted. Mayam, thank you so much for hosting and organizing all of that, and everyone who participated. Everything looks super cool, innovative, and in the motion. So super exciting. And thank you so much.
Yeah, thanks, Adam. Thanks, everyone. My pleasure. I think
Thank you.
it's all thanks to all the contributors with the excellent work. Thank you.